Yeah, yes, that's probably the best position to stand in. Yeah, thank you for the words. Mostly accurate, no. Anyway, so yeah, I think that has been said. So yeah, the whole talk is basically really because I was like super or like kind of interested like mobile devices. Like, hey, what is like on all these mobile networks. And so the actual research is like a few years old, but I would say it's like more relevant even to like today. And I started, yeah, when like the whole like iPhone jailbreaking was a big thing, and then I did this blog post about, hey, maybe when you like jailbreak your iPhone, you should like change your password. And so we did some scanning on the internet. And before we could publish our results, there was like these so yeah, I was scanning like some public IPs of like mobile network operators, and yeah, we wanted to do a talk, but then there was like this iKey worm, which was like this worm / botnet, which would just spread on like jailbroken iPhones of people who didn't change their default password, which was like Alpine. And yeah, this just spread like over iPhones, which just had public IP ranges, and it's I think mostly in Australia and maybe the Netherlands. And they would just like pop up like the things that like, hey, give us like $5, or they would like also rickroll you and like change your background image.
What's MNO for people who might not know the acronym?
Mobile network operator. So. I thought I said that. Okay. So this was like in 2009, and I had this like blog post like end of 2008. It's like, hey, maybe you should change it, and I posted a proof of concept on how to like get like data of jailbroken phones, like in a more or less automated way. And yeah, I hope like nobody actually took that code for this thing, because the code looked like very similar, and they were using the same technique, but yeah, I don't know. So this is like more or less the background of this talk, because like I was like scanning for iPhones, and I found like a lot of other things, and then like this thing came along, and then we like started to like redo all the scannings to do other stuff. So the idea was to find what kind of devices and how many devices are actually connected to like mobile networks. The security of those devices were like not really the main target, but our guess was that probably most of them were like not really configured or like secured in a decent way, because probably nobody like thought, hey, like if we put a SIM card in this device, this will not like, there's like just having an IP address like on the device was like not considered hooking it up to the internet. And it's like more or less a starting point for like, hey, what kind of device do I want to purchase next to like take apart, because it only makes sense if like these devices are like actually reachable from the internet, and maybe like do some forecast on like what kind of devices we would see in the future. Yeah. And so my main question was like, do like the mobile network operators, do they know what kind of devices their customer attached to their networks? Maybe they don't want to know, because they may be liable if like they know there's like if there's like really like badly configured stuff attached. And when you first did this, we said like, hey, what do we expect? Like as a first I was like looking for iPhones, and it's like, hey, maybe there's also other kind of mobile or smartphones. But yeah, this was like finding phones was like not the outcome of this research at all. It was way more interesting. Which is like, if you think about it a little bit more, you think, oh, okay, yeah, phones normally don't run network service, so why, yeah, or at least most of them don't. Yeah, so this is like a really more or less like lame IP scanning talk, where you just like look at IP addresses over the internet. It's more, the idea was more like to look at specific IP ranges. Yeah. So the main idea was, okay, we have this like mobile network, so you have like the mobile operator has like his core network, and then he has like the cell towers all over the country, or maybe all over the world, and we really want to know what's attached. So normally we would say, hey, of course we have like some mobile phones. I don't think those kind of phones are still around. And those guys probably are out of business soon, but yeah. But yeah, you have, of course, you have like a lot of like 3G dongles, maybe not USB connected anymore, but this is basic what you assume. But probably there's also a lot of like other stuff. And the first idea was, okay, let's just get like one of those USB dongles and hook them up to like a laptop and just like scan like the IP range. So if you get dropped to like a public IP address or even a private one, we could just like scan the network that we are dropped on and like see other devices. But many actually operators, they disable like device interconnect. So if I have this phone and even if I know the IP address of this phone and we're in the same network, they would not allow us like to connect to each other. So basically, so if you're the inter-client connection, if that's not allowed, you cannot do this kind of research. Also, if we want to scan, like if you buy a SIM card for maybe T-Mobile, I could only like scan devices on their network if I do if I only like scan the local network. Also, if I buy a SIM card from the US, then I cannot easily like be dropped on the network from, I know, in Brazil or somewhere. So, and of course, even if I can buy a SIM card from like another country and connect here, then I have to pay like a lot of like money for roaming, especially for data roaming. So it's like not really super practical. And that's why we said, okay, let's do it another way. But there's also other interesting things. Special APNs, I don't know if you're familiar with like, so this, what's this called? Access point name. So that's basically, it's not really like a VPN, but you can connect to like special, basically when you set up your like GPS or data connection, you can give it an APN and then you connect to like different like kinds of services you dropped in different networks. So if you take like some machine-to-machine or Internet of Things devices, as you would say today, and if you like get the SIM card out of those devices and get the configuration, you can maybe be dropped on like a different network, and then maybe you can like connect to all of the different devices. So this is, I did a talk about this in 2010 about like looking at like Kindle stuff. So they had like a special APN and so on. But we also saw that like if you buy like a BMW and like get the SIM card out of the car, you can also probably connect to their networks. Yeah, so access to like special hardware, extract SIM card. If you get like the APNs, maybe username and password, then you can do like other kind of scanning. But this is not at all what I did. It's just like something I briefly looked into like in terms of another talk. So the idea was like, okay, let's just look from the internet. So just take a computer, connect it to the internet, and look at all the operators, because we can like avoid a lot of problems. Also, if your device is reachable from the internet, it's having it badly configured, or it's much more interesting than if you have to get the special SIM card of the special hardware with the special configuration. Like if everybody can just like scan, I know, the IP addresses of, I know, AT&T that are assigned to like mobile devices, and then you can just like reach devices. It's way more interesting. Yeah. So what we basically did, I went to like the regional internet register databases and just like searched for interesting terms. Then I took some of the IP address or the complete IP address list of this iKey, like this iPhone worm, which was mostly in Europe and Australia. Then I took my web server logs. So I have a like special way of like parsing or like collecting data from my web server. I have like host a lot of like mobile applications, so people come often and like with their phone and visit my site directly. So I have like a special log parser to extract interesting IPs, and yeah, and then you can also just Google around for stuff. But basically, the most reliable stuff was just using the RN, like the RIPE database, and you can just like look for certain things like GPRS. So basically the idea was like we looked for like terms GPRS, GGSN. So GGSN should be GPRS something support node, which is just some like internal like name that's used for boxes like on mobile operator networks, and M2M is machine-to-machine communication. And basically came out with like 9 million something unique IP addresses. And so some problems when you like look for IP addresses this way. Of course, not all operators mark their net blocks. Hey, this is like our net block for our GPRS customers. So sometimes you like end up on some DSL range. So probably we also like missed a lot of IP addresses, but at that time I didn't have the capabilities to like do like really large scale fast scanning. So I just wanted to scan like IP addresses where like had like the certainty that it will be like something mobile. And you have other problems, like normally when you connect your phone, you mostly get a private IP address and you're sitting behind like NAT. Which is, so a lot of devices sit behind NAT, so they're not really reachable from the internet. And devices that not sit behind NAT are probably sit there for like a reason, so they're like the more interesting devices anyway. And as I said, mobile phones mostly don't have open ports besides like iOS devices, which makes them very easy to identify over this like iPhone sync service, which is like on a fixed port. So if you can connect on this port, you most likely hit an iOS device. At least in this this time, I haven't looked at like current iOS devices. And you have like way more problems, like so GPRS is like super slow, and when a device doesn't have like an open connection, it will go to sleep. And so when you want to like connect to the network, the GSM network will first page the device, wake the device up, maybe establish the data context again, and then will like slowly send data. So you have to be very patient. So you have like very long timeouts. Also, bandwidth is probably not too high, and devices move and like they get disconnected often. So when you like, if you have like some device and you like drive around in a car, go into like maybe a longer tunnel, maybe you exit the tunnel and get a new IP address. So they move around a lot. So if you don't scan like multiple times, you maybe like not scan certain devices at all. Of course, if you do like really stupid scanning, you maybe just be seen by like an operator's IDS and they just like block you for some time. So for the scanner is like not fancy at all. It's basically just like some really stupid TCP connect scanner written in Python, and I'm connecting over Tor. So at that time, I was the lab I was working was like at a university, but we also were sponsored by an operator, and you don't want to have like your like one operator being like blamed to like scan all the other operators. So Tor solved a lot of problems. First, you get like different IPs, so you have a lot of different exit IPs, and it's harder it's very hard to like actually identify you. And then of course you just randomize the IP address list and scan. And basically it was like we just did basic banner grabbing. So we implemented like really basics for some port, like some of the basic protocols like HTTP and Telnet and so on, to actually get information out. So like our our reverse record for the IP address like said like operator name in it. So that was not it's not a good one, but Tor is like super slow. So we had to had to do a lot of parallel connections. I think I ran 2 boxes, and each box had like I think 2,500 connections in parallel open at all times. So So when we started, like this was like mostly the ports we were looking at. This is like this iPhone sync port. At some point, like I decided, okay, HTTPS on those devices we found that doesn't make sense at all, because if they run HTTP, they only have HTTP. There's no HTTPS, so one port less like means a lot less time in scanning, and also these other ports were like not interesting. And as you will see later, even zip was like not really running on those devices. Yeah, so for some probes, you like added some additional features. So if SSH connects, we will try to like the 2 default passwords from iOS devices, and then run like this command, which like gives you a really good overview over the machine. And yeah, later you will see this was pretty helpful, because a lot of those devices where you can get like an SSH connection is actually not an iPhone at all. Yeah. So yeah, this is was quite useful. Yeah, basically, that's what I already said. You split up the IP address, randomize, scan all the stuff. This took a really long time, because it was running over Tor. Yeah, and then you have to, from time to time, have to fix something, and then you just do it again and again and again. Because if you scan multiple times, you will also find out like if some machine has like static IP, because it doesn't change like in a month or two. It's always like the same box on the same IP. You can, this is probably static, and which makes things more interesting. Yeah. Yeah, so this is a really old slide. Yeah, this is like, yeah. So, yeah, of course, I won't tell any IP addresses, no names of actual operators, just like the kind of boxes we found, and sometimes like maybe the country we found them in, because it's pretty interesting which countries actually have stuff, but doesn't necessarily say the operator. I think most countries have more than 2 operators, or at least 2. Yeah, basically this is like the kind of data we collected. So like just the IP port, the IP, timestamp, port status, and like a banner. Yeah. So yeah, in the beginning I just look at some of the data like by hand. You just like grab for strings, login, authenticate, welcome, whatever. Later we did some more automated analysis, and sometimes you want to like do some verification. So you search the web for like some product ID that came up, or maybe try again to like connect to the service if it like looked super interesting, or to just verify whatever you found. And we did that like in just very few cases. Yeah. So basically what I did is like some fuzzy clustering like on banners, so you could see like how many, I don't know, machines run OpenSSH or some other SSH version. And then of course try to like cluster if stuff is like in like dynamic or static, has a dynamic or static IP. Yeah, the static stuff is normally like really interesting. Yeah, and then of course like Googling for stuff again. So so now I will mostly like show you some statistics on what kind of devices, what banners, what services. Yeah, this is like all like real devices, just examples, and just like not to blame or discredit any manufacturers or operators. So I think at that time I only got one hit on like the zip port, and this is like this one hit, and this is like all we did with zip. And then after like I think 1 month of scanning, I said, okay, zip is not really interesting. Let's remove this port, and yeah. So this is like just some statistic on different like responses on FTP, and just sort of gives you like an idea of like what devices or what kind of software runs on those devices. Yeah, so those are like kind of interesting. Yeah, here you see like way more information of like different embedded systems. Let's see. Fun is always like this, like Windows CE, like all Windows CE stuff. This is like a really, you will see more about this company, Moxa. They make like basically SCADA systems from what I understand. And then you have like a lot of like embedded companies which just like do like have their own SDKs to build completely embedded devices. And you have like those network cameras and so on. So one of the devices we found in large quantities was this like a vehicle tracker manufactured by this company DigiCore. So we found over 200 devices in these different countries. And they build like basic trackers for everything, trucks, rental cars, they say like individual person tracking, and I guess also like shipping containers and so on. So that's one thing. Yeah, I didn't do like any further investigation on this one. Yeah, I didn't want to like log in and like download stuff from there. So this basically we just like took the banner string and identified the device. The one more of the more interesting devices is this is like something you have maybe if you like work at a like warehouse or like as a delivery truck driver, and when you like scan whatever product you want to like get from your inventory or like add to your inventory. And funny enough, they like are sitting on the public internet and like running an FTP server, and probably I can do a lot of like interesting things over FTP. And if it's just updating their firmware, which I suppose is like one of the features. Yeah, and then there was like a bunch of like Windows Mobile devices which I couldn't identify. Just see this like run on Windows CE, and I used to do a lot of Windows CE research in around 2004, and yeah, Windows CE is you don't have like even have to think about any kind of security on those devices. They run one user, and so this is just a lot of old, like really this is what you would expect like in industrial setups. You have like very outdated software running on insecure protocols. There's a lot of like, so these are like embedded SDKs. So we could not identify what kind of service or what kind of hardware this is, because these companies are just building like SDKs for embedded hardware. So maybe they're like worth looking into. This like falls more into the line of like, hey, what kind of like software is used in the field? Maybe you can like get the software and like do more investigation on this. Interestingly, there is like this like professional GPS or like measurement. I think like also like laser measurement. So when you like go out in the field and want to do like maybe like city or planning or something, I guess those devices are used there. And yeah, I also don't know whether they have like they sit on the internet with like FTP enabled. But it says on their product sheet, yeah, that's like one feature. And this is like a more it's like home. I don't know, it's like some measurement appliance. So this I guess like goes into a rack, and you see like here is like goes to like whatever you want to like control, and this should be like probably the antenna that connects to the for GSM. I mostly found those like on like some German network. What you found a lot, like you see like over 500 devices. Basically, it's like a GSM to an Ethernet bridge, and this is like from something from the manufacturer. They say, hey, yeah, you can connect like cameras, PLCs, or maybe ATMs. So this would be probably pretty interesting to take over. So it's just like some really basic. It's just like a GSM GPRS router, but it seems to be like very widely used. So it could be like a valuable target for like further investigation. Other stuff was like very more expensive hardware. There's like National Instruments stuff. Found a bunch of those. So there were like very few hits on FTP. So now like we start like, okay, we identified some devices, and sometimes maybe have like a really like a few like maybe I had like maybe 3 or 4 hits which said like only this national instrument string but nothing else, and then we had a bunch of those some which also had like this remote connection username, exactly this string on Telnet. And so if you find 2 devices, one device which has like both, then you can like say, okay, probably this other devices is like the same, but they disabled maybe FTP, and then you can like draw conclusions of what kind of device that is. So that was like more like the work I did after like scanning, when we like looked through all the logs. This is like really some industrial measurement stuff, and from what I looked, this like seems to be like very expensive. Yeah, and we've again found a lot of different devices and different networks. So, yeah, if you now look at like devices we found like having Telnet implementations or Telnet running. See like something Microsoft Telnet implementation. OnCell, this is again this like Moxa company which does like SCADA systems, and the other things were pretty, yeah. So this is, I think this was this National Instrument stuff. So what you would find, of course, like a lot of these like home routers, which are, I would say, pretty boring. But then you find like this really specialized environmental sensors, where you again have like different services connected. This looks like, in my opinion, like very customized hardware. So they were like just sitting all on this network. And like as you see, like most of the devices so far I covered were like had like dynamic IP. So you would see the same device, but they would like change, the IP address would change over time. This is one of the most interesting finds. So this is a traffic control system sitting on a German highway. And this thing also had like a static IP address. But it was like, I think after like half a year, like I scanned for some time, but like the IP address was static, and then after maybe half a year or maybe almost a year, it just like disappeared. But yeah, so this, so this is, I think it was like either this box or this box, which was the actual hardware. Like because it looked interesting. So like I did some more investigation, and I found like a picture from like on their website, which was like this box. And yeah, we found like 20 of those sitting all around the country. Yeah, so that was like one of the more interesting finds, which just like looks very different. Like I would say maybe this thing is like like some home router thing, which like you would put in the same category as a cell phone. Maybe this costs like $100 and not 500, but this is getting like is a little bit different, I would say. So this was like one of the like more interesting finds. Yeah, if we then switch to HTTP, you see like all the different micro HTTP servers. So Nginx, the mini HTTP. This one I've before never heard of, but yeah, this seems to be super popular. And then of course, like all this like micro HTTP servers, just probably to like run like the configuration web servers. And then if you look at like more detailed stuff, you see from different kind of manufacturers. This is just like 3G routers, and then you have a lot of like IP cameras, and yeah, this should be some we should see. So this is like building like automation things. So I think some maybe power consumption and so on. It's only a device, so maybe either they were like misconfigured, or maybe it was like some test installation. Some of them like never changed the IP, and some were like dynamic. But it's like one of the more, I think more like interesting, probably newer devices. And I guess those, if they're like really connected to like public IP address, you should find them like more often. Yeah, so getting back to like GPS tracking, which seems to be one of the like most popular applications of of this like embedded devices with like GSM. And we found like many of those devices, but we found many more, which was like harder to identify. So one device was just like spitting out, or one type of device was just spitting out this identifier. So I think this should be the IMEI, so the unique GSM hardware. And then if you look here, north, west, this could be like GPS coordinates. So yeah, if you take those, plot them, you just like directly like hit some highway in Portugal, and the operator was also like I think Vodafone Portugal. So that was always all fitting well together. And then if we take this output and look into more, then we actually found like at least like 100 devices, and most of them were like in Turkey, and only actually some were in Portugal. And they're basically, you connect to one of them, they just like spit out coordinates. And there's another vehicle tracking product was like C4D, and they've a lot of devices, all dynamic IPs, and they forgot or the configuration. So we would like telnet into the device, and you would directly be thrown to like a console. We can say, hey, retrieve last GPS position. And you could do a lot of things. So this is one of the cases where you just like connect to dump the console and then disconnect again. But yeah, you can also like see reboot and whatever you want to do. And there was like a lot of those devices.
So upload a new configuration file at the end there?
I guess.
Configure.
Yeah. So. And then I googled. I just like googled for like what this is actually hardware doing, or how does it look like, and you see like, okay, that's something I guess you connect to your car's system. Then you have like your GPS antenna and like probably some indicator. And the funny thing is, like, this exact same screenshot they also have on their website. So it was like really you could telnet into like see the screens like Google and like, oh yeah, it's really the same. They exactly have the same output. I think they just like, it's like here, this part, and you just see it's their interface. So in the whole GPS tracking is like a really common application. I wouldn't say it's like super surprising, but it would be interesting to like, if you can like follow around the device, maybe to like interesting locations. So the SSH banners, so of course those were the super popular. I think the two well-known SSH programs, SSH servers, and then you have like all these other ones. Of course, Cisco has their own. I think they just actually use OpenSSH, but just change the banner or something. And again, this company will be more interesting later. Oh yeah, so this is like a power system automation. So you can, so this has like this like GSM antenna, and then you connect it to like, probably it's like serial, but on their website they also have other devices, and it's basically to control like power in some remote place. And often you just drops you to like a root shell on this box, which is like runs like Linux without any password, and that's where our PSX, uname, ifconfig script came in very handy, because you get like immediately see like good overview of what these devices are running. So it's like some like old ARM version. I don't know if it was UC Linux on this one, but yeah. So we got like a lot of like different banners, so a lot of different hardware running all like these things. Yeah, and so it would just be sometimes we would just like see this telnet string and just like throw you like to the config console. And this is like what they're used for. So I was saying for their high performance thing for a power system automation, and then you see like this like power mass, and it's like, yeah, you don't want to put that on the internet, especially not with like a username and password. I even believe like even if they would put like a password on them, like they probably don't stand like a ping flood or something if it's I don't know. So it's like probably not a really good idea to have them on the internet. And there were like a lot of other specialized like systems, like this one is some releases like even runs like a Motorola 68K. That's like the processor that was used for like Palm OS and like before 2000. So yeah, there's some device. So I don't know what exactly they were used for, but it looks like some machine-to-machine gateway thing where we put like some serial devices on it. And then you have a lot of those like 3G professional routers. So if you have like some office somewhere in the middle of nowhere and you need like internet, probably like buy one of those devices. And they seem to be pretty popular. And some of them would like show you when you connect over Telnet like the location, so you can like in the configuration on the website you can, on this thing you can say, oh, this is like the device of this company and this our office location is maybe in Frankfurt, and when you connect over Telnet you would see, yeah, this is like the Frankfurt office, because they would just show something, some part of the configuration in there. Yeah, so I think in 2010-11, like this whole smart metering thing was like just like very hyped. So yeah, so we found, so I just like added this like slide about smart meters because we actually also found a bunch of them. But I guess like since it's like 9 devices only, and like in the one I showed earlier, the few devices in Russia, probably I guess there were like test installations. So basically it's like the smart meter is basically some device that sits in your basement, and the power company can like say, yeah, you can now like do something where you like need a lot of electricity, maybe running like your washing machine or something. And that's basically what they're made for. So you can have like intelligent power usage. And so we've found a bunch of those. I guess it's like a device like this big. And you see here, it's like here's your GPRS, output for GPRS. I guess this is X, maybe that's like an Ethernet thing. Yeah, and so this also runs Linux, of course, because why wouldn't you like run Linux on like something that controls the power? And yeah, a lot of those we got like root shells without login or a password. They could just like connect on SSH and would just like dump you to a root shell. Interesting, at that time, a friend of mine, he was working in like a research lab. They were working on, I think, exactly on those devices. And he's like, like I'm working on the smart meters, but we can't look into them because we don't like, the manufacturer doesn't give us like access to the shell to like to get like see what's like running on the device. And they're like, yeah, do you want some IP addresses? And it's like, maybe that's not such a good idea, but yeah. So apparently they didn't want this like lab to actually look what this device is doing. Yeah, and there's like other, so there's like some these devices that were like deployed in Turkey, and you would just get this welcome string. And it took me a long time to actually like find the website, but once you found the website, yeah, the admin password is of course documented in the product spec. And it also works, and then you can actually like see all this like different. And it's like, hey, it's compiled with GCC. That's really something you want to like when you log in on the terminal. That's something really important. Yeah. So yeah, and a bunch of those, and they seem to have like a lot of connectors. So that's some kind of like devices. You found, yeah. So as I said, like they're probably all like test installations because the numbers were just like so low. But since they're all running Linux, maybe you can like build your like smartphone botnet. So I don't know, like software. I heard like this company was particularly bad with software updates because the software updates have to be like signed off by the power companies. So basically, when you buy like a cell phone, like you only get your software update if like AT&T, Verizon say, yeah, you can install this, and then they like push that to their customers, and apparently this works the same. But I guess like a power delivery company has like less insight than like a mobile phone operator. But yeah, so I guess for those kind of devices should be like deployed more often. Yeah, it would be interesting to like do this whole like scan again. But yeah, at the time I was doing this, I was living in Europe, so I like didn't care too much. Now that I live here, I'm probably less likely to do this kind of research again. Yeah, and there's like more like customized applications. Like for this device, I really also didn't know if it was like some M2M platform or tracking or whatever. But yeah, I found them in large quantities. Also, again, no username, password for like for the root account. I think I'm almost at the end of the talk. But of course, since I was interested in mobile devices, we still found like a bunch of iOS devices in the scans. I found like 500,000 iOS devices sitting on public IPs, mostly identified through like this port. And yeah, about 2,000 had like SSH running on them. And yeah, so you can, yeah, so it's like, maybe it's like you cannot build like a large botnet because 2,000 devices is like not really worth it, but you can do, still do other stuff, I guess. So if you want to send like SMS spam or something, or at least like you could like just also steal like all the data that's stored, like all your pictures, contacts, whatever. You can steal all those stuff. Yeah. So that's basically Basically, I have access to a lot of different iOS devices if you want to. Yeah, it would be really interesting to do like this, all the scanning again. Yeah. And then you find like also strange stuff. I know, do you guys know about the Beagle board? Is like some ARM development board. So we found like 20 of those devices also like just sitting on like random networks. Again, of course, without username and password. But that's was not, I don't know, if you put like a device like that on a network, it's probably really because you're like doing some software development. And then of course you find like a lot of IP cameras. And interesting, that was like one network which had like, this is like always the same like IP address range. So you just see the whole like network. You just have cameras, and then you have like in this whole network you have one thing which is like the camera server. So there was like some large camera, like surveillance camera installation somewhere in Turkey. Yeah, they run like 2 different software versions. So yeah, this is like the more like the strange stuff you would find. I actually don't know if this like had like mobile data connections themselves, or they were sitting behind a bridge, or if that was like something where it just like ended up in the wrong like net block, and maybe that was like even a fixed network. But still interesting that they have they use like Waze public IPv4 address space for like putting cameras onto a network. Yeah, and I think that's like the end of the talk. So from like having no clue or basically just an idea of what like is in the network, we now know this like we have some phones here and there, but then we also have a lot of like other stuff, power management, home automation, device tracking, inventorial management. But since we only saw like devices that were like that had public IPs, and probably also since like we only scanned like 9 million IP addresses, we only probably really see the tip of the iceberg. And today I would say there's probably way more. So what you see like more like industrial enterprise stuff is probably the GPS tracking, smart meters, traffic monitoring, yeah, control stuff, supply chain management, M2M devices. That's actually was my main interest at that time, was like really looking at M2M device, because even like these parking meters where you can swipe your credit card, I'm pretty sure all of those like connect back home, or Yeah, we also built like other, at that time while I was doing that, we also built like a backpack which had like a 2G base station in it, which was running on batteries, so we could like do active man in the middle against such devices. But we actually never like managed to like find like a good time to go out and try that. I was living in Berlin at that time and we built it in winter, and it was like, yeah, standing outside in front of like those things in winter while it was like really cold is really suspicious. And then so, but yeah, that was still interesting. And we tried it like out on lab equipment, and this works pretty well. So if you just like jam the 2G space for a bit, and then everybody like hops on this thing. So some final ideas about like why we don't see stuff. Yeah. So if an operator didn't like tag their IP address space, we didn't scan it. So yeah, if operators use IP space not handled directly by this, or like not really handled, but if it was like maybe there are like net blocks which are like used, which are like not as labeled in any public database for whatever reasons. And of course, if netblock is only used for NAT, for network address translation, you also don't see anything. And a lot of the scans terminated at HTTP proxies, so many of the mobile operators just like run transparent proxies for the devices, so you would just like hit the proxy, I know 50, because it has like 50 exit IPs. And yeah, devices that don't have open ports, of course, then we can't find them. Since over Tor you can do like ICMP scanning, so we didn't do stuff like that. And of course there's also like some room for error, so if you like did something stupid, maybe some operators blocked us. But yeah, since we were like really randomly scanning, always had random exit IPs from Tor nodes, I think this is unlikely, but it could still happen. So some learning is like, yeah, we know what kind of embedded software is running like in the field, what kind of like software stack platforms or maybe single applications. There are features, behavior, default credentials, of course, is interesting. I know most of them, I don't think you don't even need like vulnerabilities, because if you like if they drop you onto a root shell, I think it's already probably game over. And a lot of them are like really easy targets. And the next, one part is like, hey, what kind of device could you buy for like to do some like interesting research on? Because you don't want to buy a device that will like maybe like nobody use, but you want to buy the device that like a couple of thousand or 100,000 or 10,000 people use. Yeah. So the conclusion more or less is like mobile networks are like full with really interesting devices, a lot of like industrial applications. Of course, or like now I would say, of course, most of the public IP addresses they use or have as like used for these M2M machine-to-machine communication devices. Static IP address assignments seem like really rare, which is, I would say, for some applications logical, because mostly the device maybe connects home, but maybe for like more interesting stuff, devices like also like have a static IP, so like the operators can connect to them. Yeah, and security doesn't really seem to be like a really strong aspect of this whole field. Yeah, root shells really everywhere. And yeah, one thing is like this GPRS hardware is like really becoming a commodity. That's, I think even like 2 years ago you could buy like a complete chip which had like everything, like basically you get put in the serial port and a SIM card and connect power to it, and you have like GPRS, I think for like $5. So you can, if you have some hardware, you can just add GPRS connections to it. And most of the industrial devices, they don't use like 3G because they don't need like a large bandwidth. You just need some way to connect to them, because maybe they send a few bytes of data they collect. And of course, many of the operators, they still have all the legacy, the hardware in the field, so they have the whole 2G infrastructure. Mm-hmm. So they really try to make money out of that by just like selling those access to that infrastructure for very cheap, so you can put them like in all of your devices. And yeah, so that's And yeah, one of the big problems if you like maybe deployed 50,000 devices or 100,000 devices everywhere in the country and they get owned, and then if they get owned, like, and you can't connect to them anymore, and if they then don't connect home, you actually have to like have people to like drive around and like replace them, because I don't think they will actually like go and like investigate and reflash. They will just like rip it out and replace them, and that could be like probably really expensive. So yeah, so that's like one of the like more interesting, like I would say long-term problems. I haven't counted, but like there were like I would say probably a few hundred devices with direct like root shell access. Yeah, and that's already it. I think we almost went exactly 1 hour, maybe a few minutes less. Maybe.